Let us look at one more aspect of the computational element of Panini. I have been saying again and again that Sanskrit language is rule-based processing. So let's now get to that part of it and try to understand how does it really work. Panini's system of applying grammatical conditions to derive words works exactly like a rule-based engine. There is a situation presented, and in the process of addressing the situation, the sutras bring the necessary and sufficient conditions to address the requirement. So this is the basic logic actually in deriving a word, any word in Sanskrit language. The sutras astonishingly resemble, if this condition is satisfied, then perform this operation. We saw iko en achi. I showed you an example in mnemonics. It's exactly, if this condition is satisfied, do this. So this is how all the sutras are, typical like a computer instruction program. Viewed in this manner, Sanskrit grammar is entirely derivational. Every word can be derived from start. Every conceivable word in Sanskrit language can be derived using a set of rules in a strict algorithmic fashion. That's what it actually means. And technically speaking, start from a base, a verbal root or a nominal root. The logic can search if any of the 3983 rules could be applied. The root is going through some transformation. At every stage of a transformation, you can now inquire if any of the 3983 rules qualify themselves to be applied. If so, apply it. We have moved one more step in this transformation. So if the rule can modify the current structure, it will perform the operation. The procedure actually stops when none of the rules could be any more applied, and when it stops, it will be a valid final word. Look at the charm of this whole logic with which every word in Sanskrit can be derived actually. And this rule-based recursive structure to language is highly amenable to computer-based processing, because this is so closer to how a computer will also try to take instructions and use an if and then condition and derive and all that. That's exactly what you find in Ashtadhyayi in some ways. So here is a flowchart representation of this entire logic. What we do is we start and we read inputs for the operation to be performed. Let I equal to 0. Now make I equal to I plus 1, which means you take the first rule and see whether the first rule will, first of all you check whether we have reached the end of the rules. No. Then read the sutra for the ith rule. Okay, first rule means first sutra. See if this sutra is applicable. If it is applicable, perform the operation. Whatever the sutra is saying, make the transformation accordingly. Reset the counter to 0. Now if it is not applicable, simply go to the second sutra. Increment I equal to I plus 1. So you go on doing this, and a time will come when we have reached the end of 3983. Therefore we will have to quit this logic and print the final result, which is a valid word. So this is exactly how it works. This is a very crude algorithm actually. There are efficient algorithms. You don't have to every time scan all the 3983 rules. More for a demonstration, I showed all these. In reality, nowadays they are developing very efficient algorithms to go over it again and again, but the logic hasn't changed. Now we actually take an example and see. Let us take the noun root Rama, and see how to derive the singular form of the third case. Third case is Ramena, which means by Rama. Ravana was killed by Rama. So we have to use now a structure for by Rama, which is Ramena. So let's see how the Paninian algorithm will work. Step 1, the noun root Rama is taken, and when you scan it through the set of rules, 4th chapter, 1st section, 2nd rule of the Ashtadhyayi will become applicable. That is the first rule which will qualify. And this rule is meant to supply the appropriate suffix for generating the third case. So you need a suffix to generate the third case. So that is what this rule 4.1.2 will supply. So as per the rule, a suffix called ta will be added to the stem ram. Now what will happen? We have got a situation where it is Ram plus Ta. When Ram plus Ta, Rama plus Ta, when it is there, you will again go back and scan and see if any rules will apply. Now you find 7th chapter, 1st section, 12th sutra will become eligible now. That rule will fire now. And what does the rule say? This rule provides certain conditions for replacing Ta with something else. So that rule will be applicable in this case. Therefore, as per the rule, Ta will be replaced by Ina. So that is what the rule will suggest. So now what we are going to do, we will remove Ta and put Ina. So now we have reached the 3rd stage, Rama plus Ina. Now again we will scan the rules. When we scan the rules, what we find is 6th chapter, 1st section, 87th rule. That becomes applicable now. What is that rule saying? This rule provides certain conditions for combining two Sandhi. These are Sandhi rules. How do you put two letters one after the other? So A plus E is actually Guna Sandhi. So that's what this rule will actually tell us. So as per the rule, when a vowel A is followed by another vowel E, both will be replaced by a new vowel A as per Guna Sandhi. Since there is A at the end of Rama followed by E, so this will apply. So it will become Rame plus Na. The A will become A and E will combine into A. So now we have Rame plus Na. Again the rules will be scanned now. Now what you will find is chapter 8, 4th section, 2nd rule will apply. That rule will become eligible now to apply. This rule provides certain conditions for replacing Na with Na. So that condition seems to work for this case. Therefore, Rame plus Na will become Rame plus Na. At this stage, all the 3983 rules will not be applicable. None of them will be applicable. Therefore, the procedure stops. So, the 3rd case of Rama is Ramena. So, that is how this rule actually derives. So, look at the charm of it. It every time scans for an applicable rule, apply the transformation, it goes through a change. Moment it goes through a change, again look for a rule which will apply, and when none of them apply, it exits the routine, and that's a valid word. Don't think you'll end up with an invalid word. This is the charm of Panini's rule-based operation, which I demonstrated with this example.